Welcome to day 4 session of Faculty Development Program on Blockchain Technology. It's my privilege to introduce today's speaker, Madhu Parvathaneni garu, mentor entrepreneur. He is extremely passionate about sharing of knowledge deeply involved in the startup mentorship ecosystems of Telangana and Andhra Pradesh, mentor and head of Makerspace. He has got great expertise in IoT, blockchain, artificial intelligence, machine learning, embedded systems, cloud computing, virtual augmented reality, game development. He has got wide work experience. He is the CEO of Make Skilled Innovation Park Solutions, Architect Lead Architect Blockchain Group, tech strategist for 7 startup on IoT drones, mentor for Atal Thinker Lab, trained and mentored more than 180,000 students, trained and mentored more than 50,000 faculty, conducted 500 plus workshops, boot camps, visited 100 plus colleges across India, conducted 50 plus faculty development programs, part of IoT Council, United Kingdom, part of IoT Software Group, Singapore, certified by RCSA Canada, certified by IRC Japan, certified blockchain developer expert. His associations with the MSME Telangana chapter, COWE Telangana chapter, Task Government of Telangana, T-Hub India's large incubator. He is a very certified blockchain developer associate, had hands-on expertise on Ethereum, Truffle, Canoni, multi-chain, Hyperledger, Fabric, Stellar, and Codra. It's a privilege to have the session by Madhu Parvathaneni sir. I request Dr. Gautami madam to proceed further. Thank you.
Madhu sir.
Huh, ma'am. Am I audible? Yes,
Yeah,
I'm there.
audible. Yeah. Madhu sir, can you start the program?
Yeah, ma'am, sure. Is my screen visible, ma'am? Can you able to see my screen?
Yeah, sir. Visible.
Okay.
Yeah.
So, very good evening, everyone. Thank you for joining me today in the Day 4 Faculty Development Program on Blockchain Technology, which has been organized by Department of Electronics and Communication Engineering, Malineni College, Guntur, AP. And before we, start talking about today's session, I just wanted to introduce my profile. Like, what are the types of projects that can be created on blockchain. So I'll be sharing this repositories, okay? So I have created dozens of projects on blockchain. So something like, enterprise resource platform for pharmaceutical in blockchain, and projects like, NFT marketplaces and stock market using blockchain. So I've designed dozens of projects on blockchain. I'll share this repository page on the WhatsApp, okay? So you can also understand what kind of projects can be created on this, blockchain technology. And also today, I just wanted to explore some kind of hands-on. I don't know how many of you are going to practice along with me, but I'll be using some tools like, Ganache. So yesterday, Lohit ji is also talking about Ganache, right? So I'm also using Ganache. So Ganache is a local Ethereum blockchain network. So where you can able to simulate your projects if you want to create on Ethereum blockchain network. So you can download that Ganache onto your laptop and you can start working on Ethereum blockchain projects. Okay, so this is Ganache. Ganache is a local blockchain because as we talk about blockchain, blockchain is a decentralized and distributed ledger technology wherein your ledger will be shared between the peers in the P2P network. That is what we have discussed in the previous sessions, right? So here, in order to have a hands-on, so we will be using Ganache. So you can download this Ganache onto your laptop. And yesterday, I guess some of you have downloaded this Ganache, blockchain server. So this is a Ganache blockchain server. It will be having 10 different accounts, and each account is having some balance of 100 ethers. So ether is a cryptocurrency in Ethereum blockchain network. So you'll have 10 100 ethers in each account. So in Ganache you will be having 10 accounts. So this will be easy for you to practice blockchain projects when you have Ganache on your laptop. Okay, so let me also open Ganache on my laptop. So Ganache is available on my laptop. I have installed it long back. So I'll just open that Ganache. I'll show you how to launch Ganache, and also how to connect this Ganache with blockchain applications. Okay, so here what we have to do is, on Ganache, Ethereum blockchain is supported. Now what we have to do is, either we have to click on quick start, or if you are an expert on Ganache, you can click on new workspace. If you are a beginner in Ganache, you can click on quick start. So whenever you click on quick start, by default settings will be created on Ganache. If you are a beginner or if you are an advanced person in using Ganache, you can click on new workspace. Then you can configure your Ganache according to your interest. Okay, so I'll click on quick start. When I click on quick start, immediately blockchain server will be running. So here you can able to see the blockchain server is like, so blockchain server is running on RPC. RPC server is nothing but blockchain server. Blockchain server is running on 127.0.0.1 colon 7545. So this 127.0.0.1 is nothing but local host, and 7545 is nothing but blockchain port number. So here the server is running on 7545. So that is nothing but the RPC server here. And also, and when you talk about mining, so here someone has to mine the data that is being transferred on blockchain, right? If you make a transaction on blockchain, there should be a miner who will be mining it. who will be validating it, who will be verifying it. So here mining status will be auto mining because the blockchain is local. If it is deployed on public blockchain, if your application wants to be deployed on public blockchain, then miners will come in place and they will validate the transaction that you made on the blockchain network, and they'll be taking some transaction fee as well. But here we cannot deploy our test projects or sample projects or research projects directly onto the main network. So on Ethereum, you will have main network, you will have test networks, and also you'll have local network. So here we will be using local network. Okay, so Ethereum blockchain is available on public network, which is called main Ethereum network, and also it is available on test networks like go early, or there are different types of test networks that is available. Okay, a ring B test network. So there'll be different types of test networks which are available, and also the third network is local network. So local network, which is indirectly means that no need of dependency on any third party. Okay, but if you want to use test networks, you have to be rely on the third parties. Okay, so since the ganache is local, so then there is no need to rely on any third party networks. Directly we can use our laptop. So you will be acting as a miner, you will be acting as a participant whenever you have a local network. Okay, so the mining status is auto mining here. So that is what we have to understand. And every network will have a network ID. Every network will have a network ID. So here on Ganache, if you see, the network ID is 5777. So 5777 is the default network ID on Ganache. So like this, every network will have a network ID. So network ID is 5777 and RPC server is 127.0.0.1:7545. And also gas price. Gas price is very, very important here. So which is nothing but we have very high gas price which is available to make transactions. Okay, so we have a gas price, very good value, very high value is there. By using this gas price, we can also make some transactions on the network. And coming to blocks, so by default block 0 will be created. I have not made any transactions on the network. By default block 0 is created. Block 0 is called genesis block, that is the initial block in the blockchain. And whenever you click on block 0, you can able to see its identity. Every block will be having a block hash. Every block will have a unique identity that is called as hashing. Hashing is a one-way function. That is what the previous speakers have introduced, right? Hashing is a one-way function. You can hash value will be created based on the transaction that is getting stored, based on the timestamps, based on the data that is getting stored in the block. Based on that, block hash will be created. So every block will be having hash. So all the blocks in the blockchain will be connected by using hash values. So here we have hash value, block hash value, and there are no transactions in this block. Okay, there are no transactions in this block because block 0 is a genesis block. We will not have any transactions in the block. Okay, but whenever you make any transaction, then from there, block 1 will be added, block 2 will be added. So based on that, blocks will be added continuously based on the transactions you make. As of now, block 0 is not having any transactions. Block 0 is not having any transactions, and thereby you cannot able to see any transaction data also. So every block will be having its hash value. So the block 0 is created by Ganache itself. Ganache itself has created this block 0. Now whenever you make any transactions, then immediately this block will be added. Okay, blocks will be added based on that. And you can able to see current block value as 0, right? So you can able to see current block value as 0. So current block is 0, which means that there is only one first block which is created. Okay, and also there is a mnemonic here. Mnemonic is very, very important if you want to import this Ganache onto the any wallet. If you want to import this Ganache accounts into any wallet, then obviously this mnemonic will be helping you out. So there is a 12 letter 12 words mnemonic will be there. So this is like a a key where you can import into the crypto wallet. And also you will have 10 different wallets accounts here. So this is 1, this is 2, this is 3. Like this you will have 10 different wallets, and each wallet is having 100 ethers. Each wallet is having 100 ethers, and every wallet will be having index value here. Index value 0 first account, index value 1 second account, and so on. You will have index 9. So 0 to 9 is nothing but 10 accounts. And blockchain follows asymmetric cryptography. So asymmetric cryptography is one important thing which you guys have to understand, that asymmetric cryptography is nothing but public and private key cryptography. So if you want to decrypt the data, you have to provide both public key and private key. So here, you will have public and private keys here. So public is this, and private will be there inside the key box. So whenever you click on key box, you can able to see private key here. Okay, so private key will be hidden, and public key will be displaying as a valid address here. So every account will have public and private. So this is what the keys is. Okay, so for this address, this is a private key. So this is a private key which you have to import whenever you are importing into the crypto wallets. Okay, so this is Ganache. Ganache is a local blockchain server. You can run this blockchain server either on Linux operating system laptop, or you can run it on any machine. Okay, whether it is Linux or Windows or Mac, you can run this Ganache on any kind of operating system laptop. Okay, the most important is RAM which is available on the laptop. Okay, so minimum 4 GB of RAM should be there if you want to run this Ganache. If the blocks are getting added, say if there are 1,000 1,500 blocks which are added on the chain, then your laptop RAM is very, very important, because when people are developing projects, okay, when people are developing projects, what will happen? They keep adding the information to the blocks, right? So when the blocks are getting added immediately, that reflects the speed of the laptop. Okay, so when you have more number of blocks, make sure that you have enough RAM to organize this blockchain. So that is the most important thing which we have to understand. And also now we have Ganache. Ganache is a local blockchain server. We have cryptocurrency called Ether. Every blockchain will have its own cryptocurrency. Bitcoin is a blockchain framework which has own cryptocurrency called Bitcoins, BTC. And now Ethereum is also one kind of blockchain. It will be holding its own cryptocurrency. Like this, anyone can invoke the cryptocurrency if they're creating blockchains. Some blockchains will have coins. So by using those coins, they used to trade on the blockchain network. So now Ethereum is the second world's largest blockchain technology, blockchain framework, which people are using for non-financial transactions. Say, for example, if you want to make a financial transaction, people are using Bitcoin blockchain framework in order to make some financial transactions. But if you want to store messages, or if you want to store files, or if you want to store some non-financial data, so for example, you wanted to store a land document. So, and now that land document cannot be stored in Bitcoin blockchain framework, because Bitcoin blockchain is designed only for handling financial data. But whenever you have non-financial data, then obviously people are looking at alternate non-financial blockchain networks like Hyperledger or Ethereum. Ethereum is a public blockchain network, right? So in this FDP program, so we just wanted to have Ethereum blockchain network and also Hyperledger blockchain network. So in the next upcoming days, people, the speakers and me also will be talking about how to develop applications on Ethereum blockchain network and also Hyperledger blockchain network. Okay, so coming back to today's topic. So this is the Ganache. Ganache is the local blockchain server, local Ethereum blockchain server in particular. So by Ganache is running on my laptop, and now I can make any kind of application that can use this Ethereum blockchain network. Okay, are you all following me? Any questions? Okay, no questions. Okay, so yesterday and on day 2 and day 3, people have discussed about smart contracts, right? So smart contracts are very, very important in Ethereum blockchain network, because if you cannot instruct blockchain to do anything directly, right? So you need some kind of uh, smart contracts which does that. So now yesterday also Lohit ji has shown you how to write smart contracts, and today also I'll be also explaining you from depth how smart contracts can be created on laptop. Maybe yesterday Lohit ji has shown you how to write smart contracts on Remix engine, right? So yesterday he have discussed about I was there in the FDP session, like uh, he has discussed about how to create smart contract on Remix engine, and also how to compile smart contracts on Remix Engine and all that, right? So I just don't want to continue the topic because I just wanted to show an alternate approach for creating smart contracts on the laptop directly without using Remix Engine. Okay, so I will not use Remix Engine, but I just wanted to tell you that Remix is an option where you can able to create a smart contracts directly on the from the browser without installing any other software. Okay, without installing any other software, you can directly compile your smart contracts on Remix Engine. Okay, but as a developer perspective, I cannot use Remix every time. Okay, because we will be developing multiple scripts on the laptop, right? You cannot put everything onto Remix, and Remix doesn't store any data. Remix doesn't have any login, so it is just for introductory purpose, right? So now what I'll do is I will use one framework which is called Truffle. So we have to understand what is Truffle. Okay, so Truffle framework. So here, if you see, I'm using Truffle framework. Okay, so Truffle is nothing but a framework in blockchain which is used to create smart contracts, which is used to migrate smart contracts, which is used to test smart contracts, which is used to deploy smart contracts. So by using Truffle framework, we can easily create smart contracts very simply. Okay, so from design to deployment, from development to deployment, everything will be taken care by Truffle framework only. So that is the main important features of Truffle framework, where you can easily test your smart contracts. You can write test cases for your smart contracts. I know, and also you can able to handle smart contracts very easily from design to deployment, which is like you can write migration scripts by using Truffle, and you can easily deploy them onto the blockchain networks. And simple management, the network management is also very simple by using Truffle. You can do it, and Truffle by using Truffle, we can easily create templates, and we can easily write smart contracts uh, externally without using Remix Engine. So Remix Engine, I'm not using Remix Engine, I'm using Truffle framework. Okay, so this is one kind of SDK. So simply in a software perspective, Truffle is nothing but software development kit. Okay, so in a blockchain perspective, Truffle is a blockchain smart contract framework. Okay, so this framework, we have to install it on our laptop by using this command npm install truffle-g. So immediately Truffle will get installed on your laptop. Make sure that you have Node. Okay, how to install Node? Node is nothing but Node.js. Okay, so nodejs.org is the website. You have to download Node and download Node onto your laptop. So by clicking on this, it's a very simple, easy installation. So we have to install Node onto your laptop, and after installing Node, we have to install this npm install truffle-g. Okay, so that the Truffle will get installed on your laptop. Are you guys following me? Where is this meeting? Where is the public? So public key is nothing but this, the wallet address which has been given here. So that is nothing but the public key. So whenever for example, so when you look at PhonePe, in PhonePe, for example, if I want to make any transaction on PhonePe, you will not ask your account number, right? You will ask your PhonePe number. So there, what is publicly available? Publicly available is a mobile number. Okay. So whenever you want to make some transaction on PhonePe, you will be asking PhonePe mobile number. So what is a mobile number that is linked to your bank account, right? So that will be act as a public. So private is nothing but the whatever that is hidden for the PhonePe, that is nothing but private. So there also you'll have public and private. So here also you'll have public is nothing but the wallet address, and private key is available in the key options on the Ganache. Okay, you guys are following me, right? Okay. So by using Node and Truffle, I hope you have understood how to install this, right? Node should be available. Okay, so I'll show you terminal. So you'll have command prompt on Windows, right? So here it is terminal. Now here, if you type node version, okay, if node is available, then you will get node version. Then immediately you will be getting what is the version that is being installed. If you want to get this, you have to install this Node.js, okay, the latest, the lifetime support 18.15.0 or any other version, okay, which is if it is already installed on your laptop, then you can use that, okay. If not, you can download this and you can install the node onto your laptop, okay. And also npm version. So then also it will also give you what is a node package manager version. So npm is nothing but node package manager, okay. So which will, it will be holding all the nodes that is getting installed on node.js, okay. So node.js and npm are both SDKs, software development kits, which is helping developers to handle packages, okay. And now by using this, we have to install, since I'm on Mac, I have to use sudo npm install -g truffle, okay. So this is the command which is which it will install truffle onto your laptop, okay. Make sure you have node and make sure you have npm sudo npm install -g truffle. If you're doing it for the first time, it will take 40 to 50 minutes, okay. So it is very lengthy software, okay. So sudo npm install -g truffle. No. Since my operating system is Mac, it is showing Mac directly, okay. Or otherwise, if you log in from Windows, it will show you Windows, okay. Windows is also there, Mac is also there, and Linux also it supports, okay. It supports Linux, images also. Okay, since I have logged in from Mac, okay, I have opened this website from Mac operating system, right? That is why it is showing Mac directly, okay. Otherwise, if you log in from Windows, it will show you Windows only. Yeah. Okay, so you have to install node npm and npm install -g truffle. Then immediately truffle will get installed, okay. So I'm just installing truffle on my laptop. It is already there, but I just wanted to show you, how to install truffle, okay. It will take some time, 5 to 10 minutes in installing truffle, okay. So today my concept is like, I just wanted to show you how to create smart contracts on laptop, how to how to create migration scripts, and how to deploy that smart contracts by using program, okay. So because in the introductory phase, you can rely on Remix engine, but whenever you go to a development perspective, then obviously you have to write scripts and you have to migrate and you have to deploy them, right? Yeah, now everything is getting installed on my laptop now. Yeah, now truffle is installed. If we want to check whether truffle is installed or not, we have to write truffle space version, okay. It will show you the version of truffle, okay. On my laptop I have truffle 5.8.1, ganache 5.7.7.7, solidity. So I guess yesterday the speaker have introduced solidity, right? Solidity is a programming language, okay, which is used to create smart contracts. Solidity is an object-oriented programming language like Python and JavaScript, okay. So if you are aware of JavaScript or Python, so Solidity is also very similar to that. But a syntax level is different, but abstract level is same, okay. So the way you write programs on JavaScript, the way you write programs on Python will be equal to the way you write on Solidity. The only thing is syntax level is different, okay. But Solidity is a high level programming language which is used to create smart contracts, okay. A node is also there, and also web3.js. So this web3.js is very, very important Web3 is an intermediate software in between front end and back end. Okay. So Web3.JavaScript. So this is a JavaScript framework. Web3 is a JavaScript framework which is used to connect front end and back end. Maybe in the upcoming sessions, I'll be also talking about Web3.js. But Web3.js as of now is an introductory package in between front end and back end. Okay, front end generally people write in HTML and CSS and Bootstrap, right? People use front end applications, right? So that front end applications will be communicating with back end by using this Web3.js. So it acts as a bridge between front end and back end. If you take any blockchain project, so any blockchain project these days, people are using full stack approach only. So every blockchain project will have front end, every blockchain project will have a back end, and between front end and back end, so back end is nothing but blockchain server, right? So you will be having blockchain on the back end, and the front end, people use different programming frameworks, right? Sometimes people use HTML frameworks, sometimes people use React JS frameworks, sometimes people use Angular JS frameworks. Front end will be different, but back end always blockchain will be the common thing for any kind of frameworks which are using in front end, right? So blockchain is backend, and front end it varies from user to user, from developer to developer. Okay, so Web3.js as of now it is just an intermediate software between front end and back end. So now here what we have to do. Okay, so Truffle is there, Ganache is there, Solidity is also installed. So Solidity is a programming language to create smart contracts. Okay, so now let me jump into desktop, cd space desktop. Okay, I'll create a folder. I'll create a folder here. Okay, so let the folder be mkdir. Mkdir is nothing but making directory. On Windows and Mac, these commands will be same. Okay, so cd space desktop. In Windows also we have to do cd space desktop, and Mac also we have to do cd space desktop. Okay, so mkdir space directory name. So we have to write directory name. For example, say FDP MLWAC. Okay, blockchain. So I'll create a folder which is called FDP MLWC blockchain. Now here I'll enter into that folder cd FDP MLWC blockchain. So now I am in the folder called FDP MLWC blockchain. Now in this folder, I just wanted to create smart contracts. Okay. So to create smart contracts, what I said, I'll be using Truffle framework. Truffle is already installed on my laptop. I'll be using Truffle framework now. Okay. So I can write Truffle space. Okay. So you can understand this command. Okay. So I guess no doubt here, right? CD's desktop, mkdir, creating a directory. I hope you are aware of these commands, right? Truffle space init. Okay. So this is the next command, which is the first important command from Truffle framework. Truffle space init. Okay. Can you able to say this? Or let me clear it. Truffle space init. Okay. Truffle space init is nothing but a command which initializes the Truffle project. Okay, so I wanted to create a smart contract project. So I'll be using Truffle framework, Truffle space init. So Truffle space init is nothing but which initializes the Truffle project. Okay, that project can be anything. Okay, it may be a carpooling project, or it can be a project which is related to stock market, or it can be related to agriculture, or it can be related to healthcare. It can be any kind of project. Okay, we have to use only one command which is called Truffle init. So Truffle init is nothing but immediately it will initialize the project. Whenever it is initializing project, okay, some kind of templates will be created. Let us understand what are those templates which are created in this folder. Okay, so I'm using Visual Studio Code. Okay, so I hope you're aware of previous commands. Huh? Yeah, these are the commands. CD space desktop. Do you want to take screenshot? You can take screenshot. What are you doing on laptop? So these are the comments. You can take screenshots if you want. Okay. So all the sessions are recording. Okay. So we will share the video record. Okay. So if you want to do it immediately, you can take screenshots of the commands. Okay. So this is Truffle INIT. So Truffle INIT is nothing but which initializes a Truffle project. And if you want to create any kind of blockchain, Ethereum blockchain project, you can use Truffle framework. By using Truffle, you can initialize the blockchain project. Let me show you what files it has created. Okay. So there is some templates will be there. So it will be creating default templates every time. So let me open VS Code. I guess VS Code, you are aware of it, right? VS Code is nothing but Visual Studio Code. Okay, so I'll be using Visual Studio Code. Okay, let me open the folder which I've created. So this is called VS Code. I guess you are aware of it, right? VS Code. So here we have to open the folder. We have to click on File. Okay, and then we have to click on Open Folder. Then immediately a box will open. And here we have to click on desktop, because on desktop we have created this folder, right? FDP MLWC blockchain. So you have to select that folder and you have to click on open. Immediately this folder will be open. Okay, so you can able to see here. So let me zoom in. Okay, you can able to see the templates now. You can able to see the templates, right? Yeah, here it is. So what are the templates here? Contracts is a folder. Okay, migrations is a folder, test is a folder. So that is what this life cycle of a smart contract. So life cycle of smart contracts involves 3 steps. One is called creating contracts in contracts folder. So we have to create contracts in contracts folder, and we have to create migration scripts in migrations folder. And if you want to test the smart contracts, then there will be test. Okay, so there are 3 different folders here: contracts, migrations, and test. Contracts is nothing but a folder which holds the smart contracts. Migrations is nothing but the folder which holds the migration scripts, and test is nothing but the folder which is holding test scripts if you want to test your smart contracts. And in addition to this contracts, migrations, and test, we have truffle config. Okay, truffle config is nothing but the configuration of truffle project. Okay, this truffle config will be holding data related to networks. Okay, so this data related to networks, to which network this truffle has to deploy the project. Okay, deploy the smart contracts. Okay, so networks will be there. So everything is in commented here. You can be able to see compiler solidity version. So SOLC is nothing but solidity compiler. Okay, C stands for compiler. So compiler, you know, right? Compiler is a software which converts high level format to low level format. So here low level format. So what is a low level format for blockchain? Low level format for blockchain is called bytecode. Okay, so bytecode will be created by solidity compiler. So SOLC is nothing but solidity compiler of version 0.8.19 is needed. That is what it is indicated here. Okay, solidity compiler 0.8.19. Okay, Mocha is nothing but the framework which is used to test smart contracts. Okay, now we have networks. So here networks, you have to understand that to which network you want to deploy your smart contract. Okay, so those settings will be there in the truffle config.js. Okay, did you understand this template? This is a file structure. Okay, so whenever you run, which command you're running here, we are running a command called truffle init, only one command. So this command is creating this structure. What is its structure? Creating contracts folder. Okay, creating migrations folder, creating test folder. In addition to this 3 folders, it is creating truffle config.js also. So this is the structure which is created whenever you run this command truffle init. I have not created this folder manually, right? Contracts folder I have not created, migrations folder I have not created, test folder I have not created, truffle-config.js also I have not created. I've just hit a command called truffle init. So I have given this command on my terminal, truffle INIT, it has created this file structure. That is what I'm saying. Okay. So any questions? Any questions here? Any questions here? Did you understand what truffle INIT is doing? Truffle INIT is creating contracts folder, creating migrations folder, creating test folder, and also creating truffle config.js. In truffle config.js, you have to specify what is the solidity compiler that is needed. By default, it will take the latest version only. Okay. And if you want to modify it, you can modify it based on the requirement that you have. And also it will be holding networks details, to which network it has to deploy the smart contract. Sometimes people deploy it onto the public test networks. Sometimes people deploy it onto the local networks. So it depends on the context. Okay, so no doubt so far, right? So I'm going back to the truffle. Okay, so here, what is the network that we are going to use? We are going to use Ganache. What is Ganache? Ganache is a local Ethereum blockchain network. So here, what is the RPC server? Okay, what is the RPC server that we are using? We're using RPC server called 127.0.0.1 colon 7545. This is the RPC server which Ganache is running, right? And we have to configure the same settings on truffle config.js. Okay, so we have to this is a second step. Okay, so the Ganache is running on 127.0.0.1 colon 7545, and on truffle config.js also we have to specify the same thing. Okay, let us do that. Okay, I'm minimizing this file structure. Let us come down to networks. Okay, so in 60th line we have networks. So here, development network. Okay, so there is a this is the JS, right? This is called JS JavaScript, and JavaScript is holding JSON documents. Okay, so here we have development. So we have this development host, port, and network ID. Okay, so we have to focus on this part. So this is the data which is related to local host, local blockchain network. So we have to uncomment these lines. So we have to uncomment these lines. So we have to remove the comments. Okay, so you can just delete those comments, and you can have this development host is 127.0.1 in Ganache. Also we have the same IP address, right? 127.0.0.1, but port number is 7545. Port number is 7545. Okay, so but what is the port number that we have here? 8545. So we have to change this. So in the place of 8545, we have to write 7545. And network ID is star, which means any network. Okay, so you can write 5777 or you can write star. Okay, star means any network. Now we have to save this file. Okay, so now we have to save this file. Control S, immediately this file will be saved. Okay, so now what is the setting which we have modified in truffle config? We have modified that, hey truffle, you have to deploy the smart contract onto the Ganache. That is what we are telling the truffle by using this config file. So we are telling the truffle that it has to deploy the smart contracts on local. Okay, 127.0.0.1 is nothing but local, and port number is nothing but 7545. Okay, so this is the second step what we have to do in truffle config. Okay, so any questions here? Do you have any questions? I guess everything is going smooth, right? And any questions now? And truffle config? No, right? Any questions you can put in the comment box. Okay, so we have a question and answer section here. Okay, if you have any doubts or if you have any questions, you can just comment there. In regular intervals, I used to check that. Okay, so let's jump to command terminal. Okay, so now we have to create a contract. Okay, now we have to create a contract. Okay, so now how to create the contract? That is the next command which we have to check. Okay, how to create contract. Okay, to create contract, so we have to write truffle space create contract space. Okay, create contract space name of the contract. Okay, what should be the name of the contract? For example, say, let us store the messages. Okay, so let us take messages. So I'll write SMS. Okay, truffle create contract SMS. So I just wanted to store the SMS messages in my blockchain network. Say I'll hit enter. Immediately contract will be created. Truffle create. What is the command? Truffle space create space contract space name of the contract. Okay, so here you can able to see the commands. Truffle create contract space your contract name. So contract name, what is the contract name which I have given? I have given SMS. So immediately what will happen on VS Code, you can check. Immediately this contract will be created. So here you could able to see what is the file name, sms.syl. What is syl? Can you comment what is syl? Syl is nothing but what is syl? So truffle create contract. So to create contract, so we have to write a command called truffle create contract space contract name. Okay, truffle space create space contract name. Okay, truffle space create space contract name. Okay, truffle create contract space truffle space create space contract name. Okay, immediately when you hit enter, immediately contract will be created on truffle file structure. Okay, very simple. Truffle create, you can take screenshot if you want. Okay, truffle create contract truffle space create space contract space name of the contract. Immediately with that name the contract file will be created. Okay, so here in contracts, as I said, there are three folders, right? Contracts folder, migrations folder, test folder. Okay, in contracts folder you can able to see sms.syl. What is syl? Can you comment what is syl? Okay, syl stands for solidity. So SOL stands for solidity. Contracts, it will be in solidity format. Solidity is one of the programming language which is used to create smart contracts. So these days people are using Golang, and also sometimes people are also using JavaScript in order to create smart contracts. Okay, but here today in the FDP context, I just wanted to use solidity programming language for creating smart contracts. Okay, so sms.syl. Now here in sms.syl, if you click on that, immediately it will be showing some program. Okay, yesterday also the speaker have introduced you what is this pragma solidity, right? What is pragma solidity? Did you remember what is pragma solidity? Can you comment what is pragma solidity? Pragma solidity. Okay, so whenever you create contract, so by using truffle we are creating contracts. Okay, so by using truffle we are creating smart contracts. And whenever you want to create a contract, you have to write truffle create. Okay, 1 second, someone is asking me the meeting link. So truffle create contract is a command which is used to create a smart contract. Okay, pragma solidity is the version. Okay, so which compiler this solidity compiler should use? Which version of solidity compiler this compiler should use? So we have written by default whenever you use truffle command, okay, it will have a version like the version of solidity compiler should be greater than or equal to 0.4.22 and less than 0.9.0. So this version, it is available here. Let us see what is the version in our truffle project. What is the version here? 0.8.19. Okay, so this 0.8.19 is in between this versions, right? So there is no problem here. Pragma solidity is nothing but instructing the solidity compiler that this particular version has to be used for compiling the below smart contract. Okay, so pragma solidity is instructing solidity compiler. It is instructing solidity compiler to use this particular version only. Okay, say if you want to use only 0.8.19, so you have to write 0.8.19. Okay, so pragma solidity 0.8.19, then what it will happen? it will use only this particular version to compile the smart contract. Okay, but whenever you initialize a project from Truffle, it will give you a range of versions, like the version should be greater than or equal to 0.4.22 and less than 0.9.0. Or if you have a particular version, if you know it, you can directly write that version after solidity. Okay, so something like this, 0.8.19. If you know what version you have on your laptop, you can directly write that. Okay, or else you can use the default thing. Okay, so pragma solidity. Next, so comments, anyways, in C programming language also we have same comments, right? So the comments are same. / is nothing but single line comment. Okay, in the single line comment we have a license. So because Solidity is an open source programming language which is licensed in MIT. Okay, so that is why we have to use this particular line by default, SPDX license identifier : MIT, which means the Solidity programming language is licensed under MIT. Okay, open source programming languages. Now here, if you see, we have contract keyword. Okay, I'm using one extension. That is why these keywords are getting highlighted. Okay, I'm using. Did you know this VS Code? VS Code, in VS Code we have extensions, right? So in extensions we have to search for Solidity. Okay, so I guess yesterday also one of the participant is asking about this. Okay, so I just wanted to show you. I'm using this Solidity extension, Ethereum Solidity language, so that it will highlight the keywords. Okay, so contract is a keyword, it is getting highlighted. Constructor is a keyword, it is getting highlighted. So this kind of syntax highlighting will be there. Okay, whenever you use Visual Studio Code. Okay, so Solidity extension, I have installed it on my laptop. That is why it is highlighting all important keywords. Okay, so all the keywords, whatever is there, that is getting highlighted by default. Okay, so here contract. So what is the name of the contract now? SMS is the name of the contract. In this contract, we have to write some logics of the contract in such a way that some action has to be done based on the project. Okay, so contract SMS flower bracket open. So inside this flower bracket we have to write contract logic. So here we have constructor. What is constructor? When constructor will be invoked, can anyone comment in the chat? When constructor will be invoked, when constructor will be called, anyone? When constructor will be called, when constructor will be called, when constructor will be invoked. So classes, right? For me, class and contract both are same. Okay, so class will be having member variables. Contract will also have member variables. Class will be having member functions. Contract will also be having member functions. As I said, this Solidity programming language is created on the top of JavaScript or object-oriented programming languages, because Solidity is the object-oriented programming language. Okay, so here classes are called as contracts. Okay, so contract will have contract variables. Okay, contract will have contract functions. So class will also have a member variables and member functions. Okay, yeah, constructor is nothing but whenever you deploy. Okay, so whenever you deploy the contract, then immediately constructor will be called, because construct will be called only for one time in smart contracts. I'm talking about smart contracts, because when you look at a normal object oriented programming language, constructor will be called whenever you create objects, right? So whenever you create objects, construct will be called every time. But here object will be created for only one time throughout the blockchain life cycle. Okay, so contract will be deployed for only one time throughout the blockchain life cycle. So construct will be called only for one time. Okay, whenever you deploy a smart contract, immediately constructor will be called. Okay, for example, say if I want to identify the owner. Okay, so I'll take one data type. So there are in Solidity there are data types like address. Okay, so there are data types like address. Address is a data type like integer in C. Okay, address space owner. Okay, so you know how to declare variables in C or any other programming language, right? So data type space variable name. So data type space variable name. Okay. So data type is nothing but address and variable is nothing but owner. Okay. So here owner, what is address? Address is nothing but public key. Okay. So address is nothing but public wallet address. Now here I'll write owner equal to msg.sender. Owner equal to msg.sender. msg.sender. What is msg.sender? msg.sender is nothing. msg is nothing but transaction. Okay. Transaction. Sender is nothing but who is calling it, who is making it. Okay. Sender is nothing but who is making the transaction. So what is a transaction here? Deploying the smart contract is a transaction. Okay. So deploying the smart contract is a transaction. So the fellow who will deploy the smart contract, you cannot ask individual person to deploy the smart contract, right? The owner will be deploying the smart contract. Only owner will have a permission to deploy the smart contract. Individual will not have any permission to use this to deploy the smart contract. Individuals will have individuals will have individual function access. They will not have, they cannot deploy the smart contract. Okay. If you're writing a contract in between two entities, like you will have first party and second party, and if you want to write a contract between the first party and second party, they'll be having the contract deployment access, right? A third person or witness cannot deploy this, they cannot write up the contract. So the first party and second party mutually will be agreeing together to write the contract. The witness will not write the contract. Okay. So here also the person who is deploying the contract will become the owner. So owner equal to message dot sender. Message is nothing but transaction. Sender is nothing but who is making the transaction. So that person address will be stored in owner. Okay, that person address will be stored in owner. So constructor will be called how many times? Construct will be called for only one time in the smart contract life cycle. In entire blockchain, contract will be deployed for only one time. Okay, in your complete life, btech will be done only for one time. You cannot have double btech, right? So it is like constructor will be called for only one time, which is like one deployment. Only one time it will be deployed. So construct will be called for only one time. Okay. So and always it is not necessary to have constructors. Sometimes you'll have constructors, sometimes you don't have constructors. Okay. So here, since we are beginners, let's forget the constructor. Okay. Tomorrow I'll show you what is the necessity of constructor. But as of now, let's delete the constructor. Okay. So let's have a build. Let's have a simple contract. So here, what I will do is I will store the messages. Okay. So messages string, right? So string messages, which means plural. Okay. So underscore messages. So here, what is the data type? So as I said, class is nothing but contract. Okay. So contract can have variables. So these are called what? These are called state variables. These are called state variables. Okay. String space string square bracket space underscore msgs. Okay. What is underscore msgs? Msgs is nothing but variable. Okay. So variable name identifier. Okay. So what is the data type now? Data type is nothing but string array. So square bracket, right? Square bracket is nothing but array. Okay. So now what is the data type of underscore msgs? It is nothing but string array. Now here I wanted to store a message in underscore msgs. For that, that we have to write a function. Okay. Your contract will have only two important things. One is called variables and second one is called functions. Now I'll be writing a function. Okay. I'll be writing a function space. Okay. Insert message of string m. Okay. String m. So anyone can insert message. Say I have given public access. Anyone can insert message, not only the owner, not only the stakeholders. Anyone can insert message. Okay. So here, whenever you're defining functions, you can create restricted access to only stakeholders. You can have a public access or you can have a private access. Okay. So all that kind of access we can create for contract functions. Okay, but string is the dynamic memory block, right? So we have to use a keyword called memory. Okay, since string is a dynamic memory block, we have to use a keyword called memory. So thereby we have to use a keyword called memory here. Okay, string memory M. Now here, what is square bracket indicates? Square bracket indicates dynamic, right? So square bracket indicates dynamic. Okay, so we are not mentioning the size of the array. So if the size of the array is not mentioned, it is dynamic. Okay, so dynamically the string array size will be calculated based on the number of messages you insert into it. So here we have to use something like underscore msgs dot push of m. Since it is dynamic, we have to use a method called push. Push is nothing but which appends the message m into the underscore msgs. Okay, so I was doing a transaction which is nothing but inserting a message. Okay, inserting a message is a non-financial transaction. Now I'm not sending money, I'm not receiving money, I'm just inserting message. This cannot be done on Bitcoin blockchain network, because in Bitcoin blockchain network we have to use financial transactions only. I'm using a non-financial transaction. That non-financial transaction is nothing but storing a message. Okay, inserting a message. So message is of string data type, so that is why I have given string memory m. Memory is a keyword which is very important for dynamic memory blocks. So m is nothing but local variable. Okay, so that variable I'm inserting it into the underscore msgs by using msgs dot push of m. Push is nothing but appending the message into underscore msgs. Getting what I'm saying? Are you all following me? Any doubt here in function insert message? Did you understand this function? Function I made public. Public means anyone can access the function. Anyone which when they have crypto wallet, they can access this message, this function called insert message whenever they have crypto wallet with them. So if you have a crypto wallet, you can insert message. If I have a crypto wallet, I can insert message, because the only thing which is important is whenever you hold crypto wallet, if you put public, they can access this function. Okay, but in the in real-time projects, what people do, people write restricted access, right? So they wanted to give access only to the people who have registered, or they'll be giving access only to the stakeholders. Okay, then instead of public, we have to write function modifiers or something like that. Okay, it depends on the context again. Okay, so any question so far? We have written one function. Okay, so we have written one function called insert message. So that insert message is inserting this m into the into the state variables. So the memory for state variables will be allocated on blockchain. Okay, so whenever you allocate some memory, so that memory will be allocated in blockchain. Any doubts here? Are you guys following me?
Wallets which are used in currency transaction, same as
Ma'am, your voice is breaking.
actually, wallets which are used in digital currency transaction, like as ID or Geo wallets are there. So that
Yes.
wallet is similar to the blockchain wallets.
Yes, ma'am. They in crypto wallets, you will be having public wallet address, right? But whenever you have public wallet address, you can make a contract function call.
So all are public.
Sir?
All are public wallets.
Yeah, all are public wallets. Then you can access this function because we have made it public. Okay. So now let us have one more function to view the messages. So yesterday also, from day one also, the people are saying that blockchains are immutable. You cannot edit the message once a message is stored in the blockchain. But on day two, when Radhakrishna sir is talking about smart contracts, so he was talking about uh, always we cannot say blockchains are immutable. There will be some circumstances where sometimes we have to edit the data inside the blockchain. So then people started talking about smart contracts. So I'll be also showing you how to modify data maybe tomorrow, but now I'm assuming that blockchains are immutable. Okay, so the data which is getting stored in the smart contracts are immutable. So I was just inserting message, I was just viewing the messages. Okay, so here for inserting message we have to take argument, but for viewing messages there is no need of argument. We have to have return variable only. Public, I'm also giving public access. Whenever you have public wallet, you can access this function. So public view, I'm giving an access called view. Okay, because I don't want to modify any data, I want to provide read only access. Public view returns. What is the data type of the return variable? So what is the data type of this variable? String square bracket, right? String square bracket. Okay, string square bracket space memory. Okay, since it is dynamic block, we have to write memory keyword. Okay, so here if you see view messages is nothing but function name. Public, anyone can access the function. View, I don't want to modify any data. Okay, I wanted to give read-only access for people who want to access this function. Okay, so here I'm not giving for insert message, I'm inserting message, so that is why I've not given view access here, so people can write data into it. Okay, so returns, it is returning what? String square bracket memory. Okay, it is returning string array. Directly it is returning string array, which is nothing but return underscore msgs. Return underscore msgs is nothing but what is the data type of underscore msgs, which is nothing but string square bracket. So that data type has to be mentioned for returns, and we have to return a variable called underscore msgs. Okay, so these are the two contract functions which I have created. One is insert message. Insert message is nothing but inserting message into the blockchain, and I'm giving public access. Anyone can insert message. And also the second function is view messages. View messages is nothing but we are returning messages here. What are the messages that is getting stored in this variable underscore msgs? I'm returning that variable so that people can able to see what is the message that is being stored. Now I have saved this smart contract. These are the two functions. So here there is no view for insert message, but there is a view for view messages because we are not modifying any data. Okay, so whenever you modify data, yesterday also Lohit ji is talking about whenever you modify data or whenever there is a change in the data, then only you have to pay transaction fee. Okay, then only we have to pay transaction fee. If you want to just view the data, if you just want to view the data, then there is no need to pay the transaction fee. Okay, so that is why public view indicates that there is no need of transaction fee. Okay, if you want to check balance on PhonePe, there is no need to pay transaction fee. But if you want to send money from one account to another account, you have to pay the transaction fee. Same here in the blockchain also. If you want to store a message or if you want to send a message, or then obviously you have to pay the transaction fee. Or if you just want to view the messages, then there is no need to pay the transaction fee. Okay, that's the difference between this view and without view. Okay. Now I have created a smart contract. Now we have to compile this smart contract. Okay, to compile this smart contract, we have to write truffle space compile. Okay, truffle space compile. Immediately it will be compiling the smart contract. Okay, it will be downloading the compiler version that is what available in the truffle config.js, and immediately it will compile the smart contract. You can able to see here compiled successfully. If you have any errors in the smart contract, it will show you the errors here. If you don't have any errors, immediately it will compile successfully. Okay, you can able to see here Solidity compiler version is 0.8.19. Okay, now it has compiled successfully. Whenever the Solidity compiler compiles the smart contract, it will convert that Solidity smart contract into artifact. Okay, so here what is the input of the Solidity compiler? Input of Solidity compiler is nothing but Solidity file. Okay, so we have given .sol file. So we have given .sol file. So that .sol file is converted into artifact. So the artifact will be available. If you see this command prompt, you can able to understand. Artifacts are written to. Artifact is stored where? It is stored in users, MS desktop, FDP, MLWC blockchain, in build folder, in contracts folder. In build folder, in contracts folder, artifact have been stored. Okay, this artifact will be generated by whom? The artifact will be generated by the Solidity compiler. Okay, the Solidity compiler will be generating the artifact. That artifact will be there in build contracts folder of the project directory. Okay, in build contracts folder, you can able to see sms.json. sms.json is nothing but artifact. Okay, this artifact will be created by this 10,000 lines. Okay, this 1,000, you'll have, if your contract is very big, you'll have 10,000, 20,000 lines. Okay, so here I have 6,300 lines. The 6,300 lines are generated by the Solidity compiler. Okay, this is called artifact. Every information related to the smart contract will be there in this artifact. Okay, so in this artifact, 2 3 things are which are very important for us to understand. The first thing is contract name. What is the contract name? Contract name is nothing but SMS. SMS is a contract name. The second thing which is important for us is ABI, application binary interface. If you want to connect with smart contract, ABI is very important. Generally, in software development lifecycle, you will have API, application programming interface. Application programming interface, what it will do? It will help us to connect with applications, right? So say you have Zomato installed on your mobile phone. What your mobile phone will do? Your mobile phone will send a request to API on cloud, right? So on cloud will be holding API server, and that API server will be accessing to your mobile app, right? So that is the application programming interface. In the similar way, in blockchain, in smart contracts, we have ABI, application binary interface. Application binary interface is very, very important if you want to connect with smart contracts which are deployed on blockchain. If you want to say a contract is deployed on blockchain, and if you want to connect with that smart contract, if you want to make some transactions on the smart contract, then you have to understand what is the ABI of the smart contract. Without ABI, if people have not given ABI to you to connect with smart contract, you cannot connect. ABI is very, very important. ABI is nothing but application binary interface. So here, if you see, this is the ABI from from line number 3 to 30th line. Okay, from line number 3 to 30th line, you'll have ABI. Okay, ABI will be holding what is inputs, what is the name of the function. Okay, and what are the function names here, view messages, and what is a mutability, mutability is there. And here, if you see, it is non-payable for insert message. Okay, what is the outputs here? We are not returning anything for insert message. For view messages, we are returning some data. So you can able to see here. So outputs is string square bracket, which is nothing but data type of the underscore MSGS. Okay, so all this data will be there in ABI. Okay, ABI is nothing but which is holding the information about your contract functions, and also what is the return data type, what is the argument data type, what is the input of the contract function, what is the output of the contract function, whether it is view or not, whether it is non-payable or not. So everything will be there in the ABI. Okay, ABI is nothing but application binary interface. But in addition to this ABI, so bytecode is very, very important. Okay, so metadata, anyways, what is the compiler version, what is the output, what is the ABI, everything will be there in the metadata, but bytecode is very important. Okay, so bytecode, so as I said, the Solidity compiler will be converting that Solidity file into bytecode. So if you see, this is a very big line, this line number 32. If you see line number 32, so this is very big line. Okay, so this is a bytecode of the smart contract. So we have written smart contract in English in Solidity language, right? So that Solidity language, what it will do, what the compiler is doing here, the compiler is converting that data into that Solidity functions into a bytecode, into hexadecimal code. So that is nothing but bytecode. So this bytecode will be deployed onto the ganache whenever you deploy it. Okay, so bytecode is very important. Okay, so we'll come back to artifact again. So in addition to this, there are different types of parameters which will be there. Okay, but they are not so much important. But bytecode is important, ABI is important, and two other variables will be added whenever you migrate it. We'll come back to it again. Okay, but as of now, ABI is nothing but application binary interface, and bytecode is nothing but the compiled code of the contract. So the Solidity compiler will be generating this JSON document. This is called artifact. Artifact is nothing but the complete information about the smart contract. Okay, so any questions now in related to this? We have compiled this.
What is the difference between ABI and binary link object blob?
Ma'am, what is the difference between
Between ABI and blob, binary link object.
ABI is nothing but complete information about the smart contract functions, ma'am. Blob is nothing but some portion of the smart contract.
Okay, so both are interfacing and both are giving the link address, the binary linkage.
Binary linkage will be there, but blob is nothing but, if you want to access one particular function, then say blob will be used. But if you want to access any kind of contract functions in the smart contract, then obviously people have to use ABI only. So any other questions on bytecode, or this artifact will be generated by the Solidity compiler. So whenever you run a command called truffle space compile. Any questions? Are you all following me? There are no questions in the chat. Okay, so no questions in the chat. Let us proceed. Now we have to create a migration script. Okay, so now let us focus on how to create a migration script. So now what we have to do is we have this migrations folder, right? So in migrations folder, we have to create migration scripts. Okay, so let us do that. We have to right click on this migrations and we have to click new file. And now we have to create a migration script. We have to give some file name. So since we are doing first migration, so we have to write one. Okay, so based on the number of migration, you have to understand this. Say if you want to do two migrations, you have to write two files with 1 and 2. Okay, so 1 underscore deploy. I wanted to deploy SMS contract. Okay, I'll keep extension as JS. Always migration should be in the JavaScript format. Okay, so migration should be in the JavaScript format. If you write 1 underscore deploy underscore sms.js, immediately whenever you migrate the contract, then Truffle will be understanding that, okay, so it has to deploy first this contract, second next contract. Okay, so say if you have two contracts in the contracts folder, then which contract you have to deploy first, which contract you have to deploy second. So based on the nomenclature, so based on the file name, we have to understand, Truffle will be understanding that, okay, so first I have to deploy this contract, second I have to deploy this contract. That is what the nomenclature is. So 1 underscore deploy underscore sms.js. So we have to write JavaScript code to migrate the smart contract. Okay, so now let us write JavaScript code for migrating smart contract. So to migrating smart contract is nothing but deploying the smart contract. So we have to deploy the smart contract onto the Ganache by using the artifact, by using the ABI and artifact. Okay, so let us do that. So const sms equal to artifact dot require of SMS. Okay, so we require this artifact. Okay, so we require this artifact which is needed, because this is the artifact which is generated by the Solidity compiler for the smart contract. So we have to write the syntax, which is nothing but const SMS equal to const SMS equal to artifacts dot require of the artifact name. So what is artifact name? Artifact name is nothing but the SMS.json, right? So SMS.json is nothing but artifact name. So SMS.json is nothing but artifact name. So the same artifact name we have to write here, const SMS equal to, okay, const SMS equal to artifacts dot require of SMS. So we are telling the truffle that this artifact is required. Okay, so that is why we have to compile, and then only we can migrate, because this is required now. Now we have to write module dot exports equal to function of deployer bracket open deployer dot deploy of SMS. So this is a syntax. Module.exports equal to. So whenever you run this JavaScript, what it is doing, it is calling the function. Okay. So what is the function here? Deployer function. What is the deployer function doing? Deployer function is deploying SMS. What is SMS? SMS is nothing but artifact. Okay. SMS is nothing but artifact. So what is artifact holding? Artifact holding is it is holding API, it is holding bytecode, it is holding the entire information about the smart contract, isn't it? So this is how we need to write a migration script. Okay, so in migration script we have to understand how many contracts you have. Based on that, you have to write number of migration scripts. If you have 2 contracts, you have to write 2 migration scripts. If you have 3 contracts, you have to write 3 migration scripts. If you have 4 contracts, you have to write 4 migration scripts. So based on the number of contracts, you have to write migration scripts. In each migration script, you have to mention what is the artifact that is required for deploying this particular migration script. So this particular migration script is deploying an artifact called SMS. So that is why I have mentioned that const SMS equal to artifacts dot required. So this particular artifact is required. I'm just loading that into SMS variable, and module dot exports equal to. So module dot exports, if you are aware of JavaScript, module dot exports is nothing but which exports the function whenever you call the JavaScript file. Okay, function of deployer, bracket open, deployer dot deploy of SMS. Immediately SMS artifact will be deployed. Okay, so whenever you compile on Ganache, no blocks will be added. Okay, whenever you compile, no blocks is added here. Okay, so whenever you compile, no blocks is added, but whenever you migrate, now I'll migrate the smart contract. To migrate the smart contract, so the command is truffle space migrate. Truffle space migrate, enter. Immediately this particular smart contract will be migrated onto the Ganache. Okay, so truffle space migrate. Once again, it will compile the program. Okay, so it is saying that everything is up to date, nothing to compile now, and it is starting migrations. So you can able to see to in truffle config.json, we have mentioned the network name as development, network ID is 5777, and block gas limit. Okay, the amount of gas it is required to mine this transaction. Okay, so it is saying that 6721975 is the amount of gas limit that is been applicable to this deployment. And here you can able to see deploying SMS one underscore deploy underscore SMS.js. So that is a migration script. It is calling deploying SMS artifact, and what is a transaction hash. Okay, so here deploying the smart contract is also a transaction. So it is having transaction hash and blocks 0 contract address. What is the contract address? So this contract address is very important if you want to access the contract. Every contract, once it is deployed, before deployment, contract will be accessible through contract name, but after deployment, contract will be accessed only through contract address. And what is a block number? Block number is 1. So this transaction is stored in which block? Block number 1. What is a block timestamp? In seconds. Okay, and account, from which account it is migrated, and what is the balance of that account, and how much gas it is used to migrate the smart contract, and what is the gas price, and what is the value. We are not sending any money, right? So 0 ethers is the money which has been sent, and total cost, how much amount of cost it is taken as a transaction fee in order to mine this transaction is 0.095208 ethers. Okay, 0.0952 0.084 ethers is the money which it is charging for storing this smart contract, for validating this smart contract onto the blockchain. Okay. Now, if you compare this 1 ETHR, 1 ether to 1 ether to INR, okay, 1 ether to INR. Today, 1 ether is almost uh, 1 ether is almost 1,47,000. So, what is the transaction fee? The transaction fee is 0.09. Okay, so if you see 0.095208 it is nothing but 1,400 rupees, 1,405 rupees, which is 1405 rupees has been charged. If you migrate this smart contract onto the main network, it will charge you 1,400 rupees. But see, what is the contract is holding? Contract is holding only two functions, right? For two functions, it is charging 1,400 rupees. Okay, and also two functions, and the memory allocated for this two functions and memory allocated for this MSGS variables, they're charging 1,400 rupees for storing data in blockchain. Okay, and also, so here we have two functions, insert message and view messages. Okay, so these two functions have been migrated onto the Ganache. So let's go back to Ganache. So in Ganache, if you see, block 1 is added. So in addition to block 0, earlier it is just block 0. Earlier it is just block 0. Now block 1 is also added. Okay, so block 1, when you click on block 1, you can able to see what is the block hash value. Okay, so every block will have a block hash value, and every block, other than Genesis block, will have transaction. So this is also having transaction hash, from which address it is transacted, and what is the contract address. Every contract, once it is deployed, will have a contract address. And this is a block which is called contract creation, right? So this particular contract is created. Let's click on that. Now you can able to see the encrypted data of your contract logic. So here in this contract, we have written some contract functions and contract variables, right? So if you see that contract functions logic and contract data has been encrypted. Okay, so all the contract logic has been encrypted. Now if you want to use this transaction data, you have to call contract functions by using your public wallet address. Okay, so you have to call by using public wallet address if you want to call the smart contract functions. Okay, directly you cannot access it because they're in encrypted format. So this is the block 1 which is now added, two blocks of smart contract, block 0, block 1. Block 1 is now added, which is nothing but migrating the smart contract onto the Ganache. So we have migrated a smart contract onto the Ganache. So we have migrated smart contract onto the Ganache by using truffle migrate. Okay, so by using truffle migrate, so we have migrated the smart contract onto the Ganache. So this is how you need to migrate. If you want to migrate, you have to create a migration script. So the migration script should call the artifact which is generated by the Solidity compiler. And whenever you call the Solidity compiler, so the Solidity compiler will be compiling the smart contract, will be converting this Solidity file into a bytecode, and that bytecode and every information related to the smart contract will be storing in this artifact only. Now the contract address is created, right? Now in the artifact, now the artifact will be updated. Okay, now the artifact will be updated. Now let us see that contract address will be also stored in the in this artifact. So let me show you where is the contract address. Okay, all the information related to the contract will be stored here. Okay, so now you can able to see. So networks 5777, events, links, address. So this is the contract address and this is a transaction hash. Both will be stored in the artifact once the contract is migrated. Okay, once the contract is migrated, you can able to see that address and transaction hash. Okay, so address is the contract address, transaction hash is nothing but the hash value of the transaction that is being generated on the Ganache. Now by using, if you see the wallets, okay, so if you see the wallets, the first from primary wallet only, from 0xD79, from the primary wallet only, the balance is been deducting. Okay, always whenever you compile or whenever you migrate, so it will always do migration on the primary wallet account. Okay, the primary wallet account is nothing but index 0 account. Okay, so index 0 account is having 99.99 ethers because some transaction fee has been deducted from this wallet account. So this is how you need to migrate your smart contract. Okay, to migrate your smart contract, we have to write a command called truffle space migrate. Make sure that you have migration script available in the migrations folder. Okay. So any questions? Okay, so like this, we have to create contract and we have to create migration script. Now let us understand how to test this. Okay, so we have test folder, right? So now let us write a simple Python script. Okay, so let us write a simple Python script, new file, and let us have something like test.py. Okay, I'll be writing a Python script. We have to install some packages related to this. So we have to install a package called web3 double equal to 5.28.0. Yeah. So this library we have to install. Okay. So pip install web3 double equal to 5.28.0. So this is the library, because in Python, no need to write from scratch. Everything is available in terms of libraries. We have to access the library and we have to do the remaining process, right? So we have to install this library, pip install web3 double equal to 5.28.0. So this library we have to install it. Once it is installed, we can import that library from web3 import web3 comma HTTP provider. Why I'm using HTTP provider? HTTP provider is required because your Ganache is available on RPC server. Okay, your Ganache is available on RPC server. Okay, your Ganache is available on RPC server. That is why we have to use HTTP provider. Okay, so what is Web3? Web3 is acting as a bridge between front end and back end, as I said. Now back end is blockchain. If you want to invoke the smart contract, you have to invoke it through Web3. Okay, Web3 is an intermediate software. It is an intermediate software between the front end and back end. Okay, so from Web3 import Web3 comma HTTP provider. So we are importing HTTP provider and Web3. Now here we have to import JSON also, because artifact will be in JSON format. Okay, JSON import JSON is a built-in library. No need to install it manually. And after this, what we have to do is we have to define a function connect with blockchain. Okay, let us have a function connect with blockchain, from which wallet we have to connect. So let us take an argument. Okay, let us take that argument. And what is the RPC server? PC server is nothing but HTTP colon 127.0.0.1 colon 7545. That is RPC server. That is what Ganache is available. Ganache is available on this RPC server. And now what we have to do, we have to create a web3 object, web3 equal to web3 of HTTP provider of RPC server. So we have to connect with that RPC server by using web3 object. So web3 object we have imported here, and we have just invoked RPC server by using HTTP provider of web3. Now it will try to connect with that RPC server. Okay, let us have print connected. Okay, let's have try and catch. Okay, so let's try connecting with RPC server. Okay, now let's have print connected with blockchain. Okay, connected with blockchain. Let's have exception case, exception. Okay, let's print error connecting with blockchain. Okay, so here connected with blockchain. If everything is fine, then it will connect with blockchain. If something goes wrong, then we can have one error statement here. Okay, and here we have to understand that we wanted to connect with blockchain, but we wanted to call the smart contract, right? So we have SMS contract. So we wanted to call it. So here the most important thing is we have to understand from which account. There are 10 wallets here, right? There are 10 wallets here. From which wallet address you want to access? That is what we have to understand. We have to pass here. From which wallet address? If account is zero, I want to access through web3 dot eth dot default account equal to, so web3 dot eth dot accounts of 0. Okay, if account value is 0, if account wallet address is 0, I'm saying that you access the primary account as default account. Okay, if not, if account value is not 0, then access that wallet address as a default account. Okay, equal to ACC. So here, for example, say I'll connect something like this. I'll connect with blockchain of 0. When I write 0, what will happen? It will just access the primary account, as a default account. So otherwise, let's have something like this. Connect with blockchain, and I'll copy this wallet address. Okay, I'll paste that wallet address here. Now what will happen? So you will be connecting with a different wallet address, right? So you'll be connecting with a different wallet address, then that particular wallet address only will be acting as a default account. If you provide zero, it will access the primary account. If you don't provide zero, if you provide some wallet address, then that based on that wallet address only, it will be acting as default account. Okay. So you need some wallet address, you need some money to make some transactions, right? Every wallet address will be having 100 ethers. So you can take any wallet address to connect with blockchain network. Okay, so you using any crypto wallet you can connect, because each wallet is having 100 ethers. So after this you have to define, so three stages here. Once the first stage is like stage one is like connecting with RPC server. Okay, connecting with RPC server. Stage two is like from which account you have to make transactions. Okay, from which account you have to make transactions. And also stage 3. What is stage 3? Stage 3 is nothing but, okay, to which contract you have to connect, you have to access. Okay, so that is there in the artifacts, right? So we have to provide the artifact underscore path equal to build folder. Okay, in contracts folder there is a JSON called sms.json. Okay, we have this artifact path available in uh, build contracts folder. Okay, now we have to convert the JSON string into JSON document. So that is something but with open artifact underscore path as cf colon. So we are opening that artifact path as cf, and we have to convert that into JSON, which is nothing but JSON dot load of f, and we have to access the ABI contract underscore ABI equal to contract underscore JSON of ABI. So you have to access, if you want to connect with smart contract, ABI is very important. Without ABI, without application binary interface, you cannot connect with contract in order to access all the contract functions. To access all the contract functions, you should have ABI. Okay. So contract underscore address equal to contract underscore JSON of, and what is the networks, and what is the network ID of Ganesh, which is nothing but 5777, and what is the address, that is nothing but contract address. So by using this contract address and contract ABI, we have to connect with contract. Now stage 4, which is the final stage. Now by using this contract ABI and contract address, we will be connecting with smart contract. So for that, what we have to do, contract equal to web3 dot contract web3 dot contract web contract equal to web3 dot eth, sorry, web3 dot eth dot contract of, you have to pass contract address. What is the contract address? Address equal to contract address, comma, ABI equal to contract ABI. So like this, we have to invoke the contract by using contract address and contract ABI, and we have to return this contract connection and also web3 connection. So from wherever you want. So this is a function which we have defined. So in this function, we have written 4 stages. Stage 1 is like connecting with RPC server, and stage 2 is from which account you have to make transactions. Stage 3 is to which contract you have to access, and what is its ABI and what is its contract address will be loaded in stage 3. Stage 4 is using that contract ABI and contract address, you will be connecting with contract. Okay. Now let us, okay. So now first let us connect with primary wallet address. Okay. Now let us connect with primary wallet address. Okay. Connect with blockchain of 0, contract, comma, let's have written variables, contract, comma, web3 equal to connect with blockchain of 0. Then immediately this function call, this is a function call, right? This will be calling this particular function, and it will be returning the contract connection and web3 connection. Now here we have to make a transaction. So transaction will have transaction hash equal to contract dot functions dot, and what is the function which we have to make contract call? So we have a function called insert message. So let us copy this function name and this particular function. Okay, let's say a message called hi hello. Okay, and let us make transact call. So transact, immediately this particular message will be made as a transaction, and let us wait until this transaction is mined. Okay, so web3 dot eth dot wait for transaction receipt. So we, whenever you are sending money on phone pay, you have to wait until you get that green color tick mark, right? So whenever you get green color tick mark, it means it is transferred. So here also we have to wait until the transaction receipt is generated. So tx underscore hash, and then let's print transaction stored in a block. Okay, now this is what we have to run. Okay, so now what is happening here, we have imported web3 and http provider, and also we have imported JSON in order to convert the JSON string into JSON document, and we have defined a function called, what is the function? Connect with blockchain of ACC. So here what I'm passing 0. So whenever I pass 0, it will be loading the default account, okay, primary account. But here in this function, we have 4 stages. Stage 1 is nothing but connecting with RPC server, and then slowly it will be understanding from which account it has to make transactions, and also to which contract, what is the contract ABI, what is the contract address. Everything is loaded in stage 3. Stage 4, immediately by using that contract address and contract ABI, your contract will be called. But inside the contract, what function we have to call? So that logic will be there here. Contract dot functions dot insert message. So which means that that particular contract is having a function called insert message, and we are passing an argument called hi hello. Hi hello is a message that we want to pass, and dot transact. So dot transact comes in place. Whenever you call dot transact, it will be charging transaction fee. Okay, now let us run this program. To run this program, we have to go to terminal, new terminal, and python space python 3 space test.py. Okay, test.py immediately. Oh, it is in test folder, right? So python 3 space test.py, immediately it will be running the, oh shit, address. Oh shit, what is this? Okay, 1 second. Here it is in 3.8. Okay, let us. Why it is not taking? Let us take the primary account address. Okay, now it's connected with blockchain and transactions stored in blockchain. Okay, let us go back to, yeah. Now let us look into blocks. Okay, now you can able to see block 2. Okay, block 2 is created. Block 2 is created, and block 2 is nothing but contract call. So we have given a hi hello, right? So that hi hello is encrypted and it is been stored in the block. Okay, this is a hi hello message which is been stored in the block. Okay, which is stored in the block from which wallet address. So here you can able to see sender address. Sender address is nothing but 0xD79, and so on. This is the primary wallet address. Okay, now you can able to see 0xD79. For example, if you want to make transaction from this wallet address, you have to copy this. Okay, you have to copy this and you have to paste it here if you want to make that transaction from that account. Okay, so now instead of hi hello, I'll say hi, how you doing? Okay, sub message. Now let me run this. Transaction stored in the block. Now let me go back to Ganache. Okay, so now let us go to blocks and you can able to see block 3 is added. Okay, block 3 you can able to see some contract call. Okay, so which means your message is been stored. Okay, your message is been stored in encrypted format. Like that, you can easily make some transactions by using Python. uh, So for test, I'm using Python, but generally we will be developing some applications on it by using React.js or Python or HTML. So we will be developing some projects. So based on that, we will be invoking them whenever we want. But here, in order to invoke the function, contract.functions.insert message.transact. So whenever you make dot transact, immediately it will be transaction. It will be doing a transaction on the blockchain. Now here, okay, now here what I'll do is, instead of making transaction, I wanted to retrieve the data from the contract. Okay, so for that, what I'll do is contract comma. Okay, I'll do one thing. I'll just copy this first line, and after this, I'll write print of contract dot functions dot. Okay, what is the second function which is made, which is nothing but view messages, right? View messages dot call. So dot call is nothing but which calls the smart contract view functions. Okay, call is used to invoke view functions, and dot transact will be used to invoke the transaction functions. Okay, so whenever the function which is non-payable, then immediately we will be using dot transact method. Now let us run this program. To run this program, what we have to do, we have to go to text folder and we have to write python 3 space test.py. Then immediately you can able to see a message called hi hello, hi how are you doing, in decrypted format. Okay, so this is the data which is stored in the blockchain. Hi hello, hi how are you doing. Okay, so these are the messages which are stored earlier by using this test program, right? So by using test program, we have inserted messages. So this is how you need to call the contract functions. Okay, so this is the logic to call transaction functions by using Python. So maybe tomorrow I'll be showing a different logic, but as of now, this is very simple. You have to connect with blockchain. After connecting with blockchain, there are two options here. One, whether to make transaction function and whether you have to make transaction or whether you have to make simple call. So if you want to make a transaction, you have to use dot transact method. And if you want to make a simple call, you have to use dot call method. But dot call method will be used only for view access permissions, for view access functions. Okay. So dot transact will be used if you want to store some data or if you want to update data, then dot transact function will be called. Okay. So this is used to make a transaction. So this is what I just wanted to show you. Whenever you make a call, block will not be added. Okay. So block will not be added whenever you make a call. Block will be added only whenever you make dot transact. So block will be getting added only whenever you make dot transact. So for dot call, there is no, if you run the program again, okay, if you run the program again, block will not be added. Block will not be added, block 3 only. Okay. But if you want to make it, if you're making a transaction, for example, say I'll comment this 2 lines, or okay, I'll comment uncomment this lines. Okay. Instead of hi, how are you doing, I'll write FDP is going great. Okay. Some message. Okay. Now I'm doing transaction. Okay. What is the transaction that I'm doing? I'm storing a message. Hi, FDP is going great. Now, whenever you run this program, okay, so it has to display 3 messages, right? Hi, hello. Hi, how are you doing? Are the 2 messages that got stored in 2 different blocks. And just now we have inserted a message called hi, FDP is doing great, is going great. That also I've inserted in a block. Now block has been added, block 4 has been added, you can able to see here. So like this we have to insert like this blocks will be inserted whenever you call dot transact method. So dot transact method will be inserting data into the block, and block will be appended to the chain. Okay. And in blockchain, every block will be connected to the previous block by using block hash value. So here block 4 is connected to block 3, block 3 is connected to block 2, block 2 is connected to block 1, block 1 is connected to block 0. Okay. So every block is connected to the previous block by using block hash values. Okay. So this is what I wanted to demonstrate today as a hands-on. Any questions now? Are you guys there? Any questions? I'll share these programs as well. Okay. Any questions, please comment in the chat box. So that's it for today. Any questions?
Shall we conclude, Madhu? Waiting for any queries.
Yes.
Okay, thank you, Madhu, for giving a very excellent introduction about your Ganeshi local Ethereum blockchain server, and regarding of the networks, and creating a contact by using a truffle funds frameworks, smart contract frameworks, and there you can create a test and deploy all these things, and creating a folders, in the folders creating contracts, migrations, test, and truffle configuration.js, and how to work on the solidity program. And the last session is completely related to your servers, RPC servers, and Web3 that import with the support of RPC servers in the stage 1, 2, 3, 4, creating accounts and accessing account transactions in accounts and adding up the blocks in the networks, and that will be observed in the migrations and all, and very deep introductions and hands-on session. And thank you once again for giving this opportunity to us to learn with the hands-on. Thank you all.
Thank you, ma'am. Thank you everyone for joining me today. We'll meet you tomorrow. Bye.